You know, sometimes in mathematics, just like in a really good mystery novel, things are not at all what they seem on the surface. An exciting new clue can turn out to be a kind of clever illusion, one that actually points to an even deeper truth. And today, we're going to dig into a case just like that. It all started right here with this number, 1.046603. Now, I know it doesn't look like much, but when it popped up completely out of the blue in a recent mathematical study, it sent researchers down this incredible rabbit hole, kicking off a whole new investigation. So, where in the world did this number even come from? Well, it first showed up in a paper that was studying these incredibly complex objects called non-holomorphic fractals. Okay, so here's the wild part. The researchers were analyzing their data, trying to see if it fit a common mathematical pattern called a power law. And when they ran the numbers, out pops this exponent, 1.046603. And what's crazy is it fit their data almost perfectly, like less than 3% error. But it was a number they had never seen before. It didn't match anything they were expecting. It was a total mystery. This, of course, immediately raised a gigantic question. A question so big, it became the entire focus of a follow-up paper. What is this number? And that really gets to the heart of the mystery. Had they just accidentally stumbled upon a brand new, fundamental constant of the universe? Some deep, undiscovered number that governs how these fractals work? Or was it all just smoke and mirrors, an artifact of their measurement? A really elegant deception. And the stakes here were actually pretty high. I mean, think about it. If it was a new constant, that could open up whole new fields of research. But if it was an illusion, figuring out why it appeared was almost more important. It would tell them something absolutely critical about the limits of their methods and the true hidden nature of the system they were studying. So to crack this case, the researchers had to bring out the big guns. They needed a whole new set of powerful, almost exotic-sounding mathematical tools to look at this problem from a completely fresh angle. First up was a concept called a Borel singularity. The easiest way to think about this is like a tool for finding mathematical hotspots. These are critical points in the system where its behavior can just change on a dime, and they're usually where all the important clues are hiding. And then, to investigate those hotspots, they used a technique with, you gotta love this name, the alien jump. This thing basically acts like a detective's super-powered magnifying glass. It lets you measure the strength and influence of the hidden structures you find at those singularities. It's how you figure out if a hotspot is the real deal or just noise. All right, so armed with this new toolkit, the team had a hunch. They started to suspect that this mysterious number wasn't some universal constant at all. They thought maybe, just maybe, it was something that only appeared because of how the system was behaving near a boundary, a kind of mathematical edge where all the rules suddenly change. So that's what they did. They started pushing their analysis closer and closer to this boundary, the specific point defined as alpha equals 1. They used this incredibly precise, high-density grid of calculations and just started zooming in, getting nearer and nearer to that edge to see what would happen. And this is where they hit gold. Look at what they found. When they looked at the system from far away in a wide window, sure enough, the number was up there around 1.047. But watch what happens as they zoom in. They narrow the window, getting closer to that edge, and the value drops to 1.021. They get even closer, and it drops again to 1.005. The number wasn't constant at all. It was drifting, and always, always downward. That drift, that was the smoking gun. It was the one clue that blew the entire case wide open and revealed the true nature of that mysterious number. So, in the researchers' own words, the number was a finite-window effective exponent. What does that mean in plain English? It means the number was an illusion created by their vantage point. It wasn't the fundamental value, it was more like an average value over the specific window they happened to be looking at. It looked constant, sure, but only when you were standing too far away. So what was the real number? The true fundamental exponent that was hiding underneath all that apparent complexity? It was 1. Just 1. A perfect, simple integer. All of that weirdness, all that mystery, it all resolved into the simplest, most elegant answer imaginable. Now, this is so much more than just a simple mathematical correction. This whole detective story, it actually reveals something really profound about how science and discovery work in the first place. So here are the big takeaways. First, what looks incredibly complex and strange from a distance can resolve into this beautiful, simple truth once you get close enough. Second, This is what scientific rigor is all about, right? It's about pushing boundaries, retesting your assumptions, and never just taking a result for granted. And finally, it's this powerful reminder that what we observe isn't always reality. Sometimes it's just an illusion created by how we're observing it.
And that just leaves us with this one last fascinating thought to chew on. This whole story played out in the world of pure math. But it really makes you wonder, doesn't it? What other scientific truths, in any field, are really just elegant deceptions, simply waiting for someone to come along and take a closer look?